You want me to just?
Hello and welcome to this webinar with the Association of Licensed Architects. I'm happy to introduce Mark A. Miller, who's going to speak today about Passive House, the world's most stringent energy efficiency building standard. If you have questions throughout this webinar, please feel free to enter them in the chat box on the lower left-hand side of your screen, and I will be reading them out later to Mark. Thank you very much, and here's Mark.
Well, good afternoon, everybody. Thanks for joining us. I am an architect and a builder with a small office here in Rogers Park neighborhood of Chicago. I went out to the University of Arizona back in the mid-'80s to study architecture, and they had an emphasis in passive solar design, which I was very interested in, and have been a champion of sustainable architecture for all this time. And last summer I went out to the West Coast where they were offering training for this new passive house standard, and it seemed to be the natural next step to the type of energy efficient design I was doing. We mainly do residential work, some commercial and retail interiors as well, but I had not jumped on the lead bandwagon with everyone else at the time. For my own reasons, but when I caught wind of the passive house approach to energy efficient design and the fact that they'd been doing this 20 years in Germany and Austria, there was a lot of science behind it, and all of those issues came together for me that just felt right. So what I'd like to do today is share with you an introduction to this new passive house standard. It's very exciting if you are into energy efficient design. And to start things off, I'm going to share with you one of the past houses I designed a couple of years ago. This is the Madsen residence. It's in the Edgebrook neighborhood of Chicago. And we used many green building techniques on this project. And I just want to share this with you to give you some context to how well I thought I was doing a few years ago to how much better we can do in terms of the performance of our buildings. So these are some of the items that were incorporated into this design. We had passive solar design. We had 2 stories of glass in the front room that received natural sunlight. And in the summertime, the leaves were out on the trees and it provided nice shading. We didn't get the extra heat gain, which would make the air conditioning work a lot harder. And then in the winter, the leaves would go away and let that nice low sun angle come in and provide extra BTUs to assist our heating. On top of that, we had an active solar hot water thermal system on the roof, and that provided the home 70% of its domestic hot water needs and 30% of its heating needs. We connected the system to the return air ductwork where there was an exchange unit, and the cool air coming back to the furnace would benefit from the heated water that was coming from the roof. Also, the project was panelized in a factory. The walls came out in 8-foot sections on 2 flatbeds, and we erected the whole house in just a couple of days. It was very fast. We saved $15,000 in carpentry labor, and the house was under roof much sooner, safe from the elements. In terms of insulation, we did the trick that everyone's doing now, which is 2x6 walls at 24 inches on center to maximize the ratio of wood structure to insulation. We used dry blown-in cellulose, dense packed into all the cavities. And then a trick I've been doing for a few years now is getting a nice layer of rigid insulation on the outside of our sheathing, which acts as a thermal break. And it increases the performance and R value of the wall quite significantly. Same with the attic hatch. 10% of the home's heat will find its way up through that simple little attic hatch that has your pull down stairs in it. We found a product called an energy guard that's basically 5-inch thick frame of rigid insulation that goes around this attic hatch opening, and then there's also a 5-inch rectangular cap that covers it. And this provided a tremendous thermal break. not letting all that interior heat, which is going to migrate upwards, to get out. We also had one of my favorite products, a solar exhaust fan. The thing I like about this is once you set it in place, you're never paying a penny to operate this thing for the life of the product. So it's a great product. The more the sun beats on it and it's heating up the roof, the faster the fan spins to exhaust that heat buildup, and you get a 50-degree temperature differential by using this fan. We also tried to do a gray water system, but at the time no one else in the city of Chicago had successfully permitted a gray water system for a residence. Now I believe there's a handful of projects that have done so, but the city wanted us to do all the testing, and we just didn't have the time or budget to do that. So how did we do using, these kind of typical energy efficiency techniques that we've been doing over the past few years? Well, if we look at a HERS index, which is the Home Energy Rating System, this is the evaluation or the test that's done at the end of a project, and it's required by Energy Star to meet their criteria. And if we look at this chart, an existing typical 80-year-old Chicago home is probably going to rate somewhere up here at 150. Now the new 2006 energy efficiency code is kind of going to reach about a scale of 100. EPA's Energy Star program, the minimum you need to do is get an 85. And what they do on these HERS analysis is they model the house noting the insulative value of the building shell, and then they also do a blower door test at the end of the project to see how airtight the house is. And between these two, this is what determines your rating. And we see that LEED is also trying to hit this 85 benchmark. Well, the Madison residents did pretty well. We not only met the Energy Star program criterion, but we actually beat it by 25%. We had a 63 on the HERS analysis, which is respectable. But now we're going to talk about Passive House. And Passive House, with its building techniques, actually comes down here to a HERS of 20, and in some cases I've heard of 10 and 5, which is outstanding. So we're talking about an exponential leap in performance, and that's what's so exciting about Passive House. Obviously, what we're all trying to do is get down to this net zero home, and in the future to go beyond that to a net positive home where our houses are actually feeding energy into the grid that is to the benefit of everyone else. So after that experience and after going through the training, I had the big aha moment. And to sum it up, it is all about minimizing your losses. That's what Passive House is about. It's about building an amazing, airtight, super insulated shell that hardly anything gets out. If hardly anything gets out, then you don't have to do much to replenish what's gone out. So you're also trying to maximize your gains, meaning the body heat coming off of people. When you're cooking with your refrigerator running all day, those latent heats are contributing to the comfort of the house. So the thought process is like this. If we can build a building that produces less energy losses, then there is less replenishing that we need to do, which costs money. That means we need less equipment to make that small amount of energy to keep the building comfortable. That's less energy to operate that smaller equipment. That's less operational expenses annually. Less regional power generation losses. We lose a lot of efficiency just transporting the power from where it's created to our buildings. And this is less global impact, which means, hooray, a lot more for everybody else. And this is the Passive House's approach. It embodies this aha moment or this realization. So let's get into now some of the details of what Passive House is about. This little schematic is kind of a nice summary. You can see that we were relying on a very nice continuous boundary of insulation on all 4 or 6 surfaces of a home. It's also, these passive homes use an ERV system for its ventilation, so you have very excellent indoor air quality. And then we're also benefiting from heat gain from our south-facing glazing. And you have an option to add renewable energy to the project to, again, get it closer to a net zero situation. So if we had to open up a dictionary and say, what the heck is this passive house system? It is a rigorous voluntary building energy standard focusing on a high performance envelope with a resulting minimized mechanical system and small space conditioning energy load. Whew. It's a mouthful, but that really sums everything up. So let's go in now and look at some of the goals of the passive house system. And the first goal is to try and reduce the space conditioning energy load for new buildings by up to 90%. This is a huge exponential difference. And how do we do this, and why do we do this? Well, if we make a chart and we look at all of our losses, we see that our ventilation system is responsible for a large chunk of our losses. Where the building is sitting on the ground is responsible for sucking out a lot of our heat in the winter. Our external walls are responsible for quite a big loss. The roof, of course, as well, but typically we insulate the roof much more than any part of the walls. And then we have our glazing, which is always the weakest link of our building envelope. So when you add up all these losses, you come up to the chart up here at 120, and now we look at, okay, what's going to replenish all of these losses? Well, we're going to get some heat gain through our windows, and then we're also going to get some heat gain through the items I mentioned before, body heat, lights, refrigerators, cooking, that type of thing. Now, everything else that we have to make up in terms of losses has to come from our mechanical system, and this is a huge amount of quantity. Now, the way the passive house approaches it is this. Look, let's shrink all the ways heat is getting out of our building envelope. And if we can shrink it down, then we could take the same heat gains as before, but now this is all we have to make up. It's exponentially smaller. So this is the approach that passive house is taking towards reducing energy demand. The next thing about passive house is that it's a performance-based and verifiable building energy metric, which means that there is software involved that has been polished and polished and polished for the past 20 years by the Passive House Institute in Germany. And all of the data that has been studied on all the homes that they have built goes back into the software, and you can you can calculate how an intended design is going to perform almost down to the BTU on an annual basis, which is a great tool for us designers to have to understand how every little detailed decision we make is going to affect our energy performance. So this chart here is explaining how our demands globally for energy is going to keep escalating on an exponential rate. And I'll put this out there if anyone wants to type in some answers, but I'd like to ask folks, from your opinion, why you think our energy demand is skyrocketing so much. Feel free to type in some answers if you'd like. But I'm hoping you're thinking of what I'm thinking. And what I'm thinking is overpopulation. If we look at a chart about timeline on the bottom and number of people on the side, we see that since the first time Neanderthal man turned into Homo sapien, it took 150,000 years to produce 1 billion people, which is right here on our timeline graph. From there, it only took 117 years to make another billion people. Well, if we fast forward today, we see that it only takes 12 years compared to 150,000 years to generate another billion people. We are almost crossing the 7 billion people mark. And so when you graph this, we are just skyrocketing in terms of the number of people on the planet. Now, when you think about this, for every person, you need, let's just say, an acre of agricultural land to produce the food that they're going to consume per year. If they're just vegetarians, it might be 1 acre, but if they're carnivores, well, then the cattle that they may consume, the cattle is going to require maybe 5 acres for them to consume 1 cow during the year. So when you add up all of the demands on our ecosystem for producing food to maintain all of this life, it starts to get scary because we have a finite amount of resources. So our energy demand is because we have to house and shelter and educate and provide civilization for all of these people. So we didn't hear any of this discussed during the elections a few years ago, and you rarely hear this in the news. And to me, this is the most pressing topic that needs to be discussed. So we could make our buildings as efficient as we want, but until we really get to the source of all this excessive demand, we're never going to win the battle. So it's all about trying to get to sustainability, and I'm encouraging all of you to continue this dialogue with everyone. So noticing that the energy demands of the world are going to keep increasing, Passive House came along as a response to this situation. And we know that about 40% of all greenhouse gas emissions are attributed to the building sector. So everyone knows, I assume, Edward Masria, the architect, who is responsible for one of the best passive solar home books done back in the 70s. Well, he has this Architecture 2030 organization, and they are challenging mankind, and especially us, the architectural community, to try and get all of our buildings to be CO2 neutral by the year 2030. And the idea is, if we can get all of the energy demand to shrink, we will shrink the supplies that are needed for our buildings. And the goal here is, if the demands could shrink and the efficiencies of renewables can come up, that at some point here at 2030, perhaps the two will meet very nicely, and that we can heat and cool and light our buildings just with renewable energy, which would be a very, very exciting milestone to meet. And if we can do that, then we are really leaving the planet in good shape for our children. And this is my hope, that we're all starting to think this way. So then one of the third goals here is the Passive House standard requires excellent envelope design, insulation, and components. So I'm going to take you on a brief little history of the evolution of passive homes. And it actually started here in the States. Oddly enough, at the University of Illinois, there was a small homes council, and they had done this prototype home called the Locale home. And some of the highlights of this super insulated structure was that it had R30 walls, which at the time was unheard of, R40 roofs, double and even triple glazed windows. It had a double entry lock door system that you see in many restaurants today. Vapor barriers. It had an air-to-air heat exchanger. And this was a big deal back then in the 70s, and from here things went forward. And this is a very exciting project up in Canada, the Saskatchewan Conservation Home. And the reason I like this project so much, if you look at a section of this structure, you will notice that they built the home up on stilts. We talked about how the ground all throughout the year is actually sucking away BTUs from the interior of the house, and in the winter this is a detriment. And I think they took that to heart in the design of this structure. You'll also notice that form is following function, and that the roof has a nice solar angle to it, so that the solar thermal panels that are mounted to the roof are getting maximum benefit from the lower winter sun angles from when you need the heat the most. You can see this idea of continuous super insulation in the walls and the roof. And then actually tried to do a gray water system, we see. And so when you add up all of these benefits of the Saskatchewan house, you find that you have an 85% reduction in energy demand. This is very significant. One of my favorite examples. So from here, we go into Canada, where most of the activity was happening in the 80s. And then in 82, this Canada R2000 program is very interesting. We can see that the government actually helped train builders on how to build better energy efficient homes. And we start to see the implementation of a blower door test around this time, which is imperative to really understand how well and how airtight the construction went. Air infiltration kills a significant amount of our mechanical systems contributions to keeping the indoor air comfortable. And so blower door tests are an excellent idea. If you're not doing it now, I highly recommend that you do it during the installation phase of your projects and then at the end of your project. So it is assumed that there were, in the mid-80s, around 10,000 super insulated homes. So it turns out a couple of professors from Germany, Dr. Wolfgang Feist, who's the head of the Passive House Institute, and Professor Bo Addison, caught wind of these super insulated buildings that were happening here. And God bless them, like all Germans do, they super engineer the prototype. And so they did a lot of research and they developed this 30-page spreadsheet to really analyze building performance in terms of BTUs, energy flow, and thermal performance. So this is one of the first structures they had done. And they were getting here a reduction of 90 to 95% of their heating and cooling load. And we see that in '96 that the Passive House Institute was founded. So now let's take a look at some applications of how we can apply this Passive House standard to a variety of architectural building types. So obviously we're mainly seeing it in the residential sector. This is a home down in Urbana. And if you're not familiar already, but Urbana, oddly enough, again, is actually the headquarters for the North American Passive House leg of the Passive House Institute. This is a home in Martha's Vineyard that was done to the standard, a much larger home. And this is also the cover of a book, Homes for a Changing Climate, that is available at the Passive House Institute website, which is passivehouse.us. And if you don't have this book, I highly recommend you getting it. It's only $25, and it's a great little presentation to share with potential clients who might be thinking or who might knock on your door and say, I'm very interested in really designing a super energy efficient home. Another home in Urbana, and again, these look like a very normal house, not crazy like some of the homes we were seeing, the passive solar homes in the 60s and 70s. You wouldn't really think twice going down the street. This one's in Germany, and you can see typically these passive homes have 2 stories of glass on the side. Oh, okay. 2 stories of glass on the south side, and they seem to taper down to 1 story on the north side. This one just finished up in Salt Lake City. This one's in Japan, which I think is a very handsome home. One of my original complaints with passive houses, and many of the structures were not so architecturally pleasing, but I think anyone would feel pretty proud about this one. So we see single family residential work is applied with the PH standard. Then a very easy one is to apply it to multifamily housing. And here's one in an urban context. Again, a couple of townhomes. So residential multifamily. We also see it for mid-rise buildings, commercial structures. And you can see all the glass on here, and it's pretty amazing that it's still meeting the system. This is a school in Europe, and a Montessori school, which again, quite a handsome architectural design. So we see commercials and schools, another use for passive house standard. And then the question everyone asks, can you do renovation with it? And the answer is yes. Here's a home in California that was retrofitted to the PH standard. You can see it even has quite a large amount of glazing. Another one, and the technique typically is you strip off the exterior siding and thicken up the walls, letting them grow to the exterior and then re-side. So retrofit, renovate, residential, and then we also see commercial retrofit as well. It gives you a little taste of how you can apply the standards. So now let's jump in here to some of the techniques, and I'm going to try and fly through this because there's a lot of information to cover. So the first thing that Passive House does is it's very strategic in its design approach. As I mentioned, there is a 30-page Excel spreadsheet that is used to analyze an intended design, and these are an example of many of the pages within that spreadsheet that are all interconnected. And it's the complete building is designed as a whole or holistic structure. So the most important page on the spreadsheet is this, the front page, which tells us a summary of how all the elements of the building are going to perform. And the goal of Passive House is to get our space heating demand down to a point that's below 4.75 kilobTUs per square foot per year. Now, the reason that's done on a per square foot basis is so that the size of the structure is less important in working with the standard. We're also trying to achieve a 0.6 air changes per hour at 50 pascals, which is our blower door test, which is not easy to achieve. So special attention is paid to the construction again. And then our total primary energy demand is trying to be under 38 kilobTUs per square foot per year. So the beauty of this is in your intended design, you can take out a couple of windows or put some windows on some other walls and in 5 seconds get a recalculation, and you can see the effects on overall annual performance instantly. And this is, again, a tremendously powerful design tool. If you wanted to add 2 inches of insulation to the exterior of your walls, boom, you can see how well that does. And once you know how much it costs you to add those 2 inches of insulation, you can do a cost benefit analysis. And this is, again, a great tool for making all of your energy efficiency design decisions. Now, climate is tremendously important as it affects the calculations of the spreadsheet. So based on where your location is, the spreadsheet's full of various zones all around the US, and you pick your zone, and the spreadsheet works with that specific climatic information. It knows the average rainfall and average temperatures all throughout the year, and again, this is just a powerful, real information to see how you're performing. So the biggest aspect seems to be making a super insulated shell. The mantra is keeping all of your conditioned air in. So in the Midwest, we're looking at walls that are going to be typically 12 to 14 inches thick to get the R values we want. You know, somewhere around a 60, 70 R in our walls and 80 plus in the roofs. Continuous insulation, floor, walls to roof. No gaps in our insulation. And now with Passive House, you really cherish this exterior building envelope. And so it's important that we have no pipe penetrations in our exterior walls. I know this is hard to imagine. It feels a challenge to design this way, but I'll share with you how you get around this. But it's important to maintain this continuous insulation because all these penetrations just start to reduce your energy efficiency. And then you, again, this point on the bottom being at diffusion open to dry out. So your walls have to be able to dry out either to the interior or to the exterior. So here's some framing examples of how we achieve these super insulated walls. And you'll notice in this example of this residence, they actually took TGIs, which are traditionally used for floors and roofs, and they tilted them up vertically to get that thicker wall. And TGIs come from 12 inches, as you know, to 30 inches in depth. So it's a great product to get that wall thicker. And the web is only 3/8 of an inch thick. So again, you're maximizing your ratio of insulation to structure. And that little web actually is so small that it is not counted as a thermal bridge. So it's a very interesting product. And we're not doing anything crazy because, as you can see, Weyerhaeuser and Truss Joist actually have details in their spec books on how to use their product this way. In this particular house, they actually constructed the walls prefabricated in a shop, and they used high-density fiberglass insulation. So the walls came out to the site ready to go. And this chart is just to bring up the point that there is a lot of design flexibility in working with Passive House. We're more interested in the overall performance of the wall and insulation system. So whether you want to use straw bales or foam or cellulose, it really doesn't matter. It's all on how these things perform. And here are those panels coming out to the job site, being tilted up into place. And an interesting design detail here, you'll see that the second floor joist, to respect this notion of no penetrations in the exterior wall, they framed a 2x4 wall just inside the exterior wall, and they set our second floor framing on top of the studs. Now the benefit of this is that these typically in platform framing, as you know, will penetrate that envelope. So they get the benefit of not doing that. Plus, we also have now a cavity for the kitchen plumbing and electrics to route themselves without penetrating our insulated wall. Very sharp technique. Here's another method, which is called the Larson truss. And this is basically a double 2x4 wall that uses these scabs of plywood to hold the second layer of 2x4s out. The beauty of this system is, again, very quickly you have a very deep cavity to fill with your insulation material, and that outer 2x4 can dip down and go below your floor plate to offer some extra insulation in front of the floor plate, which, as you know, is a weak link. Here's a sample of a staggered stud situation, which again keeps your insulation continuous and uninterrupted. Then there's two systems that seem to have come out of Canada, Remote and Persist, and the acronyms are spelled out for you here. I'm not going to read them for you, but the main idea is to get one or two sheets of rigid insulation on the outside of your sheathing, and this acts as a tremendous thermal break so that the cold cannot transfer through the structure of your wall assembly to get to the inside. And this is a very effective building technique. Even if you're not going to go all the way to the pH criterion, this is still very good energy efficient building design. Also, windows now are a huge component of a passive house. They are traditionally the weakest link in the system. Windows leak, and so the Passive House Institute does their own testing to certify windows as being good enough to use in our projects. This is a window from Germany. The company is Optivin, and you can see it's a triple glazed product. There's actually cork used in the frame of the window, acting as a huge thermal break and for its insulation properties. And these are, from what I hear from the carpenters who've installed these, the best windows that they've ever seen and easiest windows to install that they've ever had. There's only one company in the US making high-performance windows that are certified by the Passive House Institute, and that's Sirius Materials. Fortunately for all of us, they did buy the old Republic window plant in Chicago, and I understand that they are now fabricating these windows here. But this is one of the more difficult parts of Passive House, are just getting good quality building components in the US. And this is always going to be the case for the next several years, to keep encouraging our manufacturers to make better and better products. For example, this is a front door, section of a front door from a German building show, and you'll see where our doors are typically 1 3/4 inch thick and sometimes not insulated. This one is actually about 5 inches thick, and it's full of insulation, and it not only has one gasket that gets compressed when it's closed, but it has 3 to 4 gaskets. There's a question here about the costs of doing Passive House relative to traditional construction, and the word on the street is somewhere between 10 and 20% in additional upfront costs to do a Passive House construction. But you have to remember, when you're really comparing apples to apples, you have to look at the life cycle cost. And so even though you're paying more upfront initially for the upgraded windows and heavier insulation, the fact that you're reducing your energy costs dramatically per year, that there will be a point where those extras have been paid for, and then the rest is gravy. Windows are typically installed in the center of your wall. And the next topic I'm going to touch on is this thermal bridge-free detailing that we've touched on lightly. But you can see by these thermal imaging camera photographs that the doors and windows are the weak link in the system. You know, the more orange and yellow the colors, the more heat loss that we're seeing, and then the darker blues are where actually the insulation is working well. And we see in a typical stud framed home that these studs are an area that are transferring BTUs continuously. So we try and detail things for this not to happen. We can see, especially in our corners of a traditionally framed home, that BTUs are flowing out these weak links. And then where we have like the persist solution with the extra layer of insulation outside of our studs, that it does a much better system stopping this concept of thermal bridging. You know, 10 years ago, people weren't even talking about this term thermal bridging like they are today, but going through the passive house training has really brought this into the forefront of my consciousness as an architect. We see the weak links of thermal bridging here where floors meet walls, down at the slabs and foundation, where second floors meet the walls, and then also where your roofs sit on your walls. So all of these take special detailing attention to keep this concept of thermal bridging activity at bay. This is a beautiful structure in Chicago. It's the Aqua High Rise. We've all come to know and love. It's a beautiful architectural piece of art, but in terms of thermal bridging, I'm bringing this up just to express this point. And these balconies are concrete, and in the winters, you can imagine that concrete's going to soak up all that cold and transfer it to the interior. If we were to do a similar building needing a balcony with a passive house mentality, we would do it more like this. It would be a freestanding balcony with just minimum connections to the main structure, but you can see an exponential increase in performance and lessening of the thermal bridging activity with this type of mindset. Airtightness is another huge issue in the passive house design approach. This diagram indicates many weak links in our traditional building systems where we have refrigerant lines coming through exterior walls, flues for hot water heaters and furnaces, and dryer vents. Your cooking hood vents also, and recessed lighting and attic hatches and plumbing vents are all traditional areas in a home that allow large amounts of air infiltration, which just kills our heating in the winter. So passive house approach takes all of these little details very seriously to avoid these weak points in the system. And this diagram is just to illustrate the point of any gaps in our insulation, the difference in how much water per day can migrate into a wall assembly is exponential, between a tight gap being quite small and then an 1/8 or 1/4 inch gap allowing quite a bit of moisture infiltration into our cavities. Where we do have penetrations, where they're inevitable, it's important that you make those as airtight as possible. Here's some products that are used to do that: various mastics and adhesives, and some rubber gaskets for penetrations coming up and through an attic. And then I was mentioning trying not to get any utilities in our exterior walls. Again, this is from a German buildings product show, but we see a little section of a wall floor set up, and there's a product out there that uses a baseboard to run all the electrical conduits, and then there are outlets that plug into that system, and this is one technique for doing that. And you can do this today here in the States, you know, just by fattening up your baseboard detail and allowing a cavity behind your baseboard, and you can have your outlets just running along the baseboards or just in the floor outside of the baseboard. So this is achievable, and like I said, as the years tick by, there'll be more and more products on the market to make this easier to accomplish. And then the biggest part of keeping things airtight is doing these blower door tests. And again, 0.6 air changes per hour is the maximum we're trying to meet to achieve the passive house standard. This is a wonderful exercise to do if you haven't tried it yet, but during the installation phase of your project, get a fan in the doorway, kick it on, and just by walking around, you can literally hear, you can hear the air pouring into cracks and crevices. So you go around with a caulk gun or a foam canister or some tape, and you can touch up all these weak links in the system, and it makes a dramatic difference in performance. Now, everyone asks, well, Mark, if you're making such an extremely tight building envelope, what about fresh air? I mean, the air must get stale quickly in such a tight home. Well, intuitively one says that, but in a passive house, they use these ERVs, or energy recovery ventilators, as the means of the air distribution. So that there is a box somewhere in the utility room or in the basement that has two pipes. One of them is continuously bringing in fresh air from the outside, and one is continuously exhausting stale air from the interior. And this thing typically runs most of the day and night, usually at a very low CFM, like around 60 CFM. So it turns out that actually a passive house has much better indoor air quality than traditional home that's built today. If we do a little cross section through an ERV, it kind of looks like this, with fresh air coming in and crossing the path of the outgoing air from the home. And they usually come in two systems. One is this flat plate system, where the outgoing air is on one layer and the incoming on the other, and the metal transfers the BTUs from the outgoing air into the airstream of the air coming in, for a net loss of anywhere between 75% to 90% efficiency. So you're only losing 10% to 20% of your energy, which is really fantastic. This rotary reel type has these pie-shaped filters that actually suck up the BTUs of the outgoing air, and as the wheel rolls around, those BTUs are transferred to the incoming air. And the nice thing about this is these filters are also continuously filtering the air 24/7. So if you want to have good indoor air quality, the 3 steps that we know about are trying to limit the source of things that are working against your clean air, pets, carpets, that type of thing, paints. Second is to bring in fresh air from the outside. And then the third is filtration. And these all are part of the passive house system. So now the last item here is space conditioning. And if you do all the techniques we just went over, it turns out that in most residential situations, the only heat that's needed to be generated is typically satisfied with an 1,000-watt electric inline heating element. Well, as we know, 1,000 watts is what your standard hair dryer uses. So it is pretty impressive that you can reduce your energy demand down to a point where only a hair dryer is going to heat the house. This is fantastic. We talked about using internal heat gains to supplement heating. Now, again, there's a lot of flexibility in passive houses, so you still can use ground sort heat pumps, geothermal. Earth tubes we'll talk about on another webinar, because that's a whole nother discussion. But some people are using these tubes that are below the house to preheat the air, outdoor air, as it's coming into the ERV. And there's some benefits to this, but it's a little bit tricky to pull this one off. Ceiling fans are used many a time. And then how do you get your cooling? Well, most passive houses are using this mini split system. We see a lot of the Japanese manufacturers making them. And they do both heating and cooling. You see these sometimes in hotel units. But it's a small package unit that will do both heating and cooling. And again, not much is needed to keep a passive house comfortable. So there's financial savings in shrinking your mechanical systems that you will benefit and be able to put that money elsewhere in the system to buy your more expensive windows. So, how much time do we have left here?
15 minutes, and I think about 10.
Fine. Okay, this is the last leg of the presentation. And what I wanted to do was share with you how the architectural process is tweaked slightly for when you're doing a passive home, and how you incorporate the software for studying an intended project that's setting off to meet the Passive House certification. So let's review the architectural process with this added on. And this is also how a Passive House consultant would be used by your offices if you had a client that wanted to try and achieve a super energy efficient home. You can call up one of us Passive House consultants, and we would be part of your team and offer consultation during the process. So for example, the pre-design phase work, there'd be conversations we would contribute at the table discussing your energy efficiency goals, discussions on siting of the house, because all of that has a huge influence on the annual performance of the home. And then again, solar orientation also is going to affect the performance of the intended design. The second phase of the process is the schematic design phase. And passive houses seem to favor a floor area to building envelope ratio as close to 1 as possible. So a home that is very rectangular is more detrimental to your energy performance from the view of passive house than a square home is. So we can discuss that. And then square footage obviously has a huge impact on energy demand. And the passive house community is encouraging the American market to really get away from the whole McMansion thing and live comfortably in a smaller amount of square footage. And most of you, I'm assuming, are familiar with Susan Susanka's books, the Not So Big House books. I think she's got about 9 of these out there now, and if you don't have one, I encourage you to get them. But she has many interesting design techniques using alcoves, nooks, small bay windows, and multi-purposing rooms that you take all these little design benefits and put them into a house, and you can actually reduce the number of rooms that you typically would be designing. So this is a very, very important part of the passive house approach. And then the impacts of fenestration sizes and locations and orientations and shading on the intended design and performance of the home is another part of the architectural process dialogue. So the third phase is now when you get into design development, this is where I believe you want to jump onto the spreadsheet and model the home and enter all the design information, and we will know at this early phase of the design development portion how well we are performing. We'll know how many BTUs per square foot per year the intended design is going to achieve. And if we are over it, how we can do multiple studies by increasing insulation in the roof, increasing insulation in the walls or under the slab, or taking away a few windows or changing orientation of windows. And again, every 5 seconds we have a new computation that tells us the benefits of those. And this is a tremendously powerful design tool. You will never look at design the same when you start to use this worksheet to help influence your design as an architect. So we'll study the super installation and value engineer all of these approaches, because every design decision has a dollar price tag associated to it. And this is how you make smart decisions for all of your clients, by giving them hard, good facts and evidence of why it's justifiable to do this design technique or that design technique. Then again, we just talked about the fenestration. So we actually have another spreadsheet that can show your clients how the increase in cost, slight increase in cost to do some of the passive house techniques can be seen on a timeline here to the point where the upfront costs have been have been neutralized by the energy efficiency savings and fuel costs. So for example, this particular house at year 14 has paid itself off. And this is looking at an annual increase in energy costs of only 1% a year, which, as we know, is probably ridiculous. There's a question that's just come up: is there passive house software for Revit? And there are efforts going on right now to link Revit to this spreadsheet that I'm sharing with you, so that as you're designing and tweaking the size and shape, that it would continuously upgrade the passive house spreadsheet. So that is in process, yes, and that'll be a huge victory when that is ironed out. So I feel here in the design development process, once we've got this spreadsheet to a point where we are exceeding the criterion to meet the passive house standard, then it is safe to proceed to CDs in confidence. So then during step 4 of the process, during your CD phase, you can use the passive house consultant to help you with the detailing of all these critical areas of your building envelope to keep them thermal bridge free, to again keep discussing the details of the wall, roof, and floor assemblies, and then to also start designing the ventilation system that's based on this ERV or HRV. And then also do our best to help point out any airtight issues in your design. Ultimately, they say if you do the airtight layer properly, you can take your pencil and outline that layer all the way through a cross section of your building, and it should be continuous. Your pencil should never leave the paper. And then a huge part, as we all know, is everything comes down to dollars. So working with you to share with your clients which techniques are worth the money and which just aren't is a benefit that's brought to the table. So then during the construction administration phase, you live and die by how well your project is built. And it is important to have a pre-construction meeting with all the players involved to stress to them the importance of this airtightness and to make sure the plumber doesn't bore holes in your exterior envelope and puncture your airtight layer. So it requires more attention, much more attention. So then during construction, as I mentioned, during the installation phase, we can come out and visit the project and visually inspect to make sure everything's being done to achieve the passive house standard. Air tightness, again, we'll put on the blower door and go around and fine-tune these weak links in the system. Here's your opportunity before drywall occurs. You know, once you start drywalling, you lose a lot of this opportunity to take care of these small imperfections. And then also, we'll help make sure the quality of the window and installation is up to par. And then we will assist with the final blower door tests to meet this 0.6 air changes per hour. Also to balance the system once it's installed, because there's some fine tuning that has to happen. And then we'll assist you in doing the documentation required to meet the passive house standard, and that's getting some of the information on the windows that were used and insulation, and then also submitting the final spreadsheet to the Passive House Institute, because they have to examine it as well to verify that your calculations are correct. The other nice thing about working with Passive House is that everyone wants to achieve the same goals and to design much better homes and buildings. And so actually during the design process, you have the benefit of the headquarters of the North American Passive House Institute, where we will communicate with them and share with them the intended design during the design development phase. And you have this extra set of eyes that are looking over the spreadsheet to make sure everything is looking good and no little details have gotten overlooked. And then finally, we're here for support to the homeowners or building owners after you've walked away from the project. If any issues should come up, there is someone there to help them out. So I have set up this website, passivehousemidwest.com, and I encourage you, if you have any clients who are considering really pushing the envelope and doing a high-performing home, there's kind of an overview of Passive House, the benefits, the techniques that you can share with them. Also, I'd encourage you to write down the passivehouse.us website, and you can go on there to find out more information about the Passive House movement, not only in the US, but internationally. And you can be aware of conferences and lectures that'll be coming up all throughout the year. And then we have started here in Chicago, I'm one of the co-founders for the Passive House Alliance. And we meet monthly down at the Hyphala showroom on Hubbard. And if you are finding that you're very interested in learning more about Passive House, you're welcome to find us. You can Google us. We have a meetup group on the web, and you're welcome to join, and we'll again give you information on upcoming meetings, and we have educational lectures each month too about various building component products that are used for passive homes and the latest and greatest building science information. So that is kind of an overview of the Passive House, and I hope you've learned something from our time together. And I think we have a little time we have a few minutes to take some questions. So if something is in your head that I can attempt to answer, I'm happy to do that at this time. There's a question about, is it possible to get a copy of the spreadsheet? And the answer is you have to buy it. It is part of what's called the Passive House Planning Package. And I believe it's somewhere around $150 to $200. You would go to the passivehouse.us website, and you can purchase, you would get, I think, about a 100-page spiral-bound booklet that talks about how to enter information into the spreadsheet. But if you're serious about using the spreadsheet, again, it's very complicated. The smallest little mistake will mess up your results. So I encourage you to work with a certified Passive House consultant, or encourage you to sign up for the Passive House training. And there's 4 or 5 different events around the country throughout the year that you could take this training. Let's see, there's a question. Your analysis use of square footage criteria, shouldn't you be using cubic feet? It is using cubic feet. That is taken into account. I just did not mention it. But the results are being viewed in the square foot metric. But the volume is calculated and analyzed in that spreadsheet. Is the PowerPoint presentation available? I do have a PDF version of this, and if you email me through my passiveHouseMidwest.com website, I'd be happy to give you a copy of that. There were 2 questions about that. How much are the consulting fees on a house? They seem to be ranging in the $3,000 to $5,000 range. And right now, to get the certification, it is much less expensive than LEED, and I think that's somewhere in the $800 range.
So I just want to say thank you to Mark Miller for his very educational presentation on Passive House. And should you have more questions or issues, please contact Mark directly, and also feel free to contact the ALA. Thank you again, and have a great day.